Okay, it's our next session in this series. Welcome, everybody. Um, we had a question today that just came up. So when I looked this morning, there wasn't any question, but now there is a question. That's great. And someone is asking about the Fortran version of the HDF5 library from using that from C, C++ when working with column major data. Can I say some more about this? Is the difference simply how the arguments are interpreted? Or is it possible to discern from the file itself whether the data is column major or row major? Excellent question. First, in the interest of full disclosure, I have to explain that I know very little about Fortran, so I wouldn't consider myself a Fortran programmer. So everything I say needs to be taken with a pinch of salt. But so maybe to explain a little bit of context here, certainly you can call the Fortran versions of the C library HDF5 calls from C or C++. It's basically, if you look at the object code, when that code gets compiled, of course, these Fortran functions will have certain symbols in binary code. So typically, that's going to be like H5D read underscore F, or sometimes the assembler will append or the compiler will append an underscore. So it might be H5F read underscore F underscore, or sometimes it's double underscore, sometimes it's a leading underscore. It really, different compilers have different conventions. And that's great. So you can certainly refer to that symbol. The other thing is that to be cautious about is that the calling convention is a little different. So from my understanding, it is that when you pass an argument, let's say an integer argument, what looks like passing an integer argument to one of these Fortran functions, you actually have to pass that by reference. So it appears I'm passing, let's say the variable name is I, the formal parameter name is I. It appears that, okay, I'm supplying a value for I, let's say 15, but you really, you don't pass it by value. Rather, you have to create an integer variable that has value 15, and then you would pass, when you call it from C or C++, you would provide a pointer to that variable, and that's what you would pass to that Fortran function, just to make sure that it gets called correctly. So that's one thing to look out for. But the important thing is to come to the sort of second part in this question is it possible to discern from the file itself whether the data is column major library unless necessary due to compression? So you apply filters, you do something actively to the data set elements. The HDF5 library does not touch your data. It really takes the data set elements, depending on if you're going from memory to the file or you come from the file and go to memory. The HDF5 library really takes them in that order and places them in the file in that order, and the same thing on the way back. So that's why it is not possible to tell in the file. So there is no attribute, no magic marker, no additional piece of metadata that would say, oh, this data set was put in the file by a Fortran program or something like that. That's or by MATLAB or Julia or something like that. That's not the case. If that information is relevant to you, you have to keep track of that yourself. And of course, the net effect of that is, let's say, consider a two-dimensional array, rows by columns, then in the C major layout, in memory, consecutive array elements would typically consist of consecutive elements in memory correspond to consecutive elements in a row. So you would first in memory, starting at address X, you would have the first row of elements in that matrix. Then you would follow with the second row of elements. Of course, this is a linearly increasing one-dimensional range of addresses, of virtual addresses in this case, in the process. And they would be arranged row by row. And if you were to look in the file, that's how they would end up in the file. Row by row, just let's assume the data set is contiguously laid out, so it ends up in a contiguous byte region. But even if it gets chunked, then on each chunk, the data would be laid out sort of in this row by row fashion. Now, if you, of course, do that from a Fortran application, then the philosophy is different. You would really, the data would be laid out. You would have first the elements that correspond to the first column in this two-dimensional array, then the next column and the next column. And what that means, when again you look at the file, that's how the data will appear in the file, as column, and so forth. So if you now, you are in a situation where you read, let's say the data was written with a Fortran program, and you read the data into memory from a, let's say, a C application, something that expects the data in a different in a different layout, then you have to deal with it. So unfortunately, and you can see that if you look at in the GitHub repository in the source code, when you look at I believe there's a Fortran subdirectory. In that Fortran subdirectory, there are these wrappers, and there is typically, I believe, an F90 wrapper and a C wrapper. And the C wrapper pretty much calls the C function or the declaration of the corresponding C call, and then the F90 wrapper just calls that C call. So it's really a very thin layer. That thin layer does not do any transposition or reordering or something like that. It's really, it reads the data as is, and that's how it delivers it into memory, or the other way around. So unfortunately, there is no extra bookkeeping that would let you discern whether this was written in this convention or that convention. And you really have to track that information yourself if that's important to you. Okay, so I hope that answered that question. It was a little hand-wavy because, again, I'm not a Fortran programmer, so we can have a discussion on the forum about this if this didn't answer the question or I said something wrong. But that's as far as I understand it, and from just reading the question, that's how I understood that question. Okay, are there any other questions for the moment? No? Okay, then I'll just move on with a few highlights and announcements. The usual announcements, yeah, you've probably seen it on the forum. The ECP BOF, that took place now probably 2, if not 3 weeks ago. The slides, unfortunately, there's no recording but the slides are available now, and I put the link here. It's just a PDF. We will have another webinar on April the 30th, I'm sorry, at 11 a.m. Central, and we are talking about performance variability in the HDF5 library due to different choices that you make regarding the layout of your data, whether you favor groups over data sets or multiple data sets in a group and so forth. So where you make that trade-off between data and metadata. And we have after that another webinar coming up about HDF5 in the cloud. And here's an interesting project presented by someone from, I believe, NASA, and the work that they have done with HDF5 files in Amazon's AWS S3 object store. And just as a reminder, we still have an active call for this year's HDF5 users group meeting out there. And you can apply for either presenting, submitting a paper and give a presentation, or do presentation only. Deadline is plenty of time between now and then, June 1st, and then the actual event is going to be roughly middle of October. Okay, so those were the announcements, and we have a few items from the forum, but again, are there any other questions at the moment? Then we obviously will answer questions rather than going over prepared material. Any questions? No? Okay, then we'll just continue. There were several interesting, there are always interesting things on the forum. Number one is documentation is going ahead. And in this particular post, we talked about sort of the next steps. Long story short, we were in the process of revamping our reference manual for starters, and putting it using Doxygen for that purpose. And we had a branch going parallel to our develop branch, where we basically put all this Doxygen commentary and annotation, and that is now as complete as it can be, and has been reviewed, and we merged it into develop. So from now on, any changes to that reference manual will go the usual pull request process into develop, and then as needed propagated to releases such as 1.12.1, the upcoming release, which is pretty close to develop at the moment, but then also 1.10 and 1.8, and we will see for which releases of 1.10 and 1.8 we will sort of do that push down into those releases. And then, of course, there are some interesting questions about, well, there is documentation that is rather release specific, like the API, the C API, for example. But then there is other documentation that covers multiple releases, or there might be some nuances, some variants in there that apply to many different versions. How do we factor out that content? That's going to be an interesting question, and we haven't really decided or made up our mind how precisely we will be doing that, but that's definitely something to work out. Pull requests are welcome. Again, this will be part of the usual release process, and documentation is as important, if not more important, than writing good code. Writing good documentation is very important. And there are certain things that we would like to get feedback on. In the notes, you will see these are all hyperlinked. There are some examples here. Of course, we will have the reference manual documentation, the typical, here's a function, H5D read, what are the types of the arguments, what does it return, what are sort of the pre and post conditions. But then each of these modules, if you want to call these H5A, H5B, and so forth modules in the HDF5 API, I think, or we think at the moment, it might be a good thing to first kind of describe what do these functions, what do the functions, what's the purpose of the functions in that module, what does a typical life cycle for an item or an object in this module look like, and then give you some examples. And by life cycle, I mean things like, let's take a data set, for example. Well, data sets are typically being created, they are being read, and they are being updated or written, and then in some form, sometimes they are deleted or destroyed. So people sometimes use this CRUD acronym: create, read, update, delete. So for some of these, this makes perfect sense. And here are some examples. For data types, for example, that might be a little different, but sort of for the main object types like data sets, attributes, files, open, yes, create, reading from a file, sure, maybe reading some metadata about the file. And then there will be actually a call that also lets you delete an HDF5 file, but I believe that's coming in 1.12.1. So if you have any feedback on these types of introductions, whether that's a good idea for some of the examples that are there already, whether you like them or don't like them, those are the kinds of things that we would like to know, and to make it as good or better, as good as it can be. Okay. I'm going to pause here. Are there any questions in addition to this, related to this or related to anything HDF5? No? Okay. Then I'll just continue. This was a thread that's been going for a while now, but it's good that sometimes maintainers of other software get involved, and that was the case here. This was where a user had problems with creating a Darshan profile from a running application, and we were able to sort of create a very simple example, and it appeared that there was an issue in the way Darshan gathers some of these statistics and so forth. And one of the developers on that project, Rob Latham, he replied on that thread and confirmed that there was an issue there. He describes in pretty great detail there was a divide by zero that occurred when certain ranks weren't writing any data, and so that will be addressed. And yeah, so it's always great if the maintainers and developers of software in the wider ecosystem get involved and are responsive, and so just great. Now, are there any other questions so far? Otherwise, I'll just keep pressing on here. There was one question about where a community member actually replied to it. The author of the HDFQL package actually replied to this question a user had, where the user wanted to copy, and that's where I went back to the initial question, and in my mind, I understand that the user wants to achieve something, and he also posted a screenshot there, but after rereading his post, it wasn't clear to me anymore exactly what he wanted. So I encouraged him to maybe rephrase what he wanted. Basically, he, from the description, he had a group and certain other groups and maybe data sets and so forth. And then he had a symbolic link that referred to one of the groups. So if you open, and he posted a screenshot from HDF view, in the forum, if you look at this group, that is the thing that appears as a group that is really a symbolic link, you see beneath that group, because HDFU will traverse that symbolic link and render the entities that are visible or linked to that entity referred to by the symbolic link. So that's all good, but then he was basically saying that he wanted to copy the group that is actually the symbolic link, and that's where it gets tricky, because if you think about it, a group is first and foremost a collection of links. So plus it may have attributes. So copying a collection of links with some attributes maybe to create a copy of that collection, including its attributes, but including in particular all the links that this group contains. Copying a link means something different. When you copy a link, then in a way you have to specify what that means. It could depend on the type of link, and that copying operation could also be interpreted differently. So for example, let's say a link has a source and a destination. So the source is implicitly the group in which this link is stored. And now when I want to copy that link, I can copy it inside of the same group. I can copy it to a different group. But then the question is, well, does that mean in the destination, be it the same group? That wouldn't quite work, because I cannot have two links of the same name in the same group. So the link, the copied link in the same group would have to have a different name. It could have the same destination or the same target, but it cannot have the same name. Now, if I copy that to a different group, then of course, if there is already a link of that name, that's not going to work. But let's assume there is no link of that name in the destination group, then that's fine, and we are maintaining the destination. Now, what might be the case in this case is that the user is actually also implying that he or she wants to, in addition to maintaining the destination of the link, they want to also have it as, well, I copy it, but then I also want to traverse that link, so resolve the destination and either have some kind of recursive behavior or have some recursive behavior with some selection mechanism where I can say, well, if the target contains, in this case, other links, depending on if they are symbolic or hard or external, I want to do different things, or the link name starts with an A, then I want to include it in that copy process. But if the link doesn't start with an A, if it starts with a Z, then I want to skip it. All these things are certainly possible, but unfortunately, it wasn't clear from the description what exactly the user tried to achieve. So that's why it's always good to ask for clarification and maybe resolve it that way. But yeah, so if you can go there and follow that thread and decide for yourself if you had the sense of that there was a clear problem statement and I just didn't understand it, which is always a possibility, or whether there was the question wasn't formulated precisely. Okay, I'm going to pause here and ask, are there any other questions in the meantime related to this or anything else, HDF5? No? Okay, then I will just move on. Tips, tricks, and insights. And what I'm going to do today is we sort of go around to talk about functions. I believe last time we spoke about, I think we spoke about identifier management. Oh no, we talked about the close degree for files. This week, let's for a moment talk about one of the interesting, they are all interesting in their own way, but one interesting tool that's among the command line utilities that ships pretty much with every version of HDF5. It's this tool called H5stat. And as the name suggests, you would think that it gives you some statistical, some kind of summary information about an HDF5 file, and that's what it does. So here, if you just type h5stat, I believe, without any arguments, or h5stat-h or --help, you get pretty much this printout where you can indicate different kinds of statistics that you might be interested, that you want to suppress, that you can set certain thresholds, or if you use a specific virtual file driver, then you can set that here. So for example, let's say you use the S3 virtual file driver or the HDFS virtual file driver, then you can pass additional arguments for that. Another thing is, yeah, sometimes tools generate errors either because of a bug in the tool itself, or because there's something wrong with that HDF5 file. It then helps typically to enable the error stack to give you more information if you then want to go out to the forum or contact the help desk. That is always appreciated if you can give us more specific information. But let's see a specific example. Let's see this tool actually in action. So here's the output from H5stat from an HDF5 file that I had sitting in a directory. It will give you information like this. It will tell you the number of unique groups. Why is that term unique important? Well, as we in a way touched on a moment ago, the fact of the matter is that since a given group can be linked multiple times under different names, it can be referred to through symbolic links, for example, and so forth. But a symbolic link to another group does not make a new group. It's really just a symbolic link to the same group again. So that's where this unique comes from, and it applies the same way to data sets and named data types and so forth. So this tells you really how many unique groups, not multiply linked, not counting duplicates or multiple instances. This is really the unique number of groups. Likewise with data sets, named data types, links. Then it's also interesting to know the maximum number of links to a given object. So in this case, that looks unusual, but it's certainly possible. So you can have objects that are referenced, that are linked many times, be it either symbolically or through a hard link. And this formulation is slightly misleading. A group contains links, not objects. But with that caveat, you can also ask, well, yeah, in a given group, how many links are in that group? And in some groups, there are very few links, and then in some groups, there might be very many. So this is one where you have a lot of links in that group. And then there is some information about the size of the superblock here, 48 bytes. That's completely normal unless there are extensions present and so forth. There is no user block here. There is information about how many bytes you spend in storing object header data, data sets excluding compact data, because in the case of a data set with compact layout, what some people call raw data is actually stored with the object header, but then of course you don't want to mix the payload of that data set with the pure object header information, and that's why there is a distinction. Then depending on how your groups are stored, there are internal HDF internal data that is being stored, like B trees and lists and heaps and so forth. So great breakdown here. And then we get sort of a little bit into the stats part where, and that's where you can use command line arguments to decide for yourself, well, what do I consider to be a small group or a large group, or and sort of this is a little bit like a poor man's histogram, if you want to read it like that. Very interesting. And then break down by the different layout types for data sets, whether filters are present. So here we see only chunk data sets, 351 of them, and 350 of them have the shuffle filter applied, and then a user-defined filter, which could be like LZ4 or one of those filters that don't come out of the box with HDF5. And so plenty of helpful information, the number of object attributes and so forth. So I recommend try that with your own tool. Also, if there is unused data present in your file that you can get rid of with H5 repack in older versions of the library, but then in newer versions you can turn on free space management to track that free space and use it. This tool is a great source of information there. But time is up, and that was it for today. Thanks for coming, and join us next time and ask questions as always on the forum or next time we get together. Thank you. Bye.